Hello and welcome students. In this lecture, we are going to deal with the concept of functions. In earlier lecture, we have completed relations. Now, when I say relations, what do I mean? I mean we have understood the meaning of relation from one set to another set. We have understood what is the meaning of relation from set A set A to set B. We have understood the meaning of relation from set A to set B. Now we are going to check the meaning of, we are going to understand the meaning of functions. That is functions. See, I'm writing functions, so it is a plural. But if you want to make it singular, then what you will write, you are going to understand the function from one set to another set. So what is the next idea? What is the next concept that we are going to deal with? We are going to deal with, we are going to deal with, we are going to understand a function. We are going to understand what is meaning of a function from set A to set B. We are going to understand what is the meaning of function from set A to set B. So let us begin. See, in the beginning, at the outset of the discussion, I would like to first of all mention one very important note. I would like to mention a very important note and see what is it. The note is a function from set A to set B. A function from set A to set B is a special relation. It is a special relation from set A to set B. From set A to set B. Now remember students, if you have followed this statement, if you remember this statement, mind it that you will understand that a function is nothing but a relation, but it is a special kind of relation. A function is also a relation, but it is a special type of relation. It's a special relation from set A to set B. So at least now you are comfortable with the idea. See, you have understood what is relation from set A to set B. You have understood it. A relation from set A to set B is nothing but a subset of A cross B. A relation from set A to set B is the subset of Cartesian product set A cross B. So as the function will also satisfy this condition. A function you will define, see, a function which you will define will also be definitely a subset of A cross B. If you are defining a function from set A to set B, remember students, if you are defining a function from set A to set B, this function will also be a subset of A cross B, like a relation you defined. The function will also be a subset of A cross B. That is, a function from set A to set B will also have set of ordered pairs. Now see, there are so many things common in function and relation. Then what is it which is making us say that a function is a special type of relation? Remember students, every function is a relation. Every function that you define from set A to set B, if you define a function from set A to set B, remember students that every function you define from set A to set B it is going to be a relation from set A to set B. But if you define a relation from set A to set B, then there has to be a condition, then only it can be a function. Not always a relation is a function. I repeat once again, every function is a relation, but not every relation is a function. Okay, so this also, see, this statements I'm writing here, and after the discussion we will see that you have understood these all statements. Okay, so here I write every function from set A to set B. See, here we write set A and set B just for the sake of names. As such, you know, you can write from set P to set Q, from set M to set N. That is okay. See, from one set to another set, that is what it is. So every function from set A to set B is a relation, from set A to set B. But every relation from set A to set B, every relation from set A to set B may not be a function, may not be a function. Now I write the definition of function. I write the definition of function. See, a function f. Okay, like we write relation as R, we are writing function as f. Okay, and later you will understand that this is just a symbolic notation. You can write even G, you can write H. Okay, it is just a symbolic notation. You know, students, in mathematics we need symbols for making it, for the sake of brevity, that is making it faster. So a function f from a set A to set B is a relation, from set A to set B. As I said, every function is a relation. That's what I'm writing. A function f from set A to set B is a relation from set A to set B. Now the special thing will come, students. Be alert. Which associates let me change the color, for each element x in A. Now see, definitely you are defining a function from set A to set B. A will have elements, so as B. The elements of A, I'm denoting them by x. There can be 5, 10, 15 number of elements in A. What I'm writing, I'm using a variable for those elements. I'm writing for each element x in A, a unique, let me change the color again, a unique means exactly one. A unique, that is exactly one element y in B. Okay, so here, this is the definition of function. This is the definition of function. What did you write? You wrote a function f from a set A to set B is a relation from set A to set B, is a relation from set A to set B, which associates for each element x in a unique, that is exactly one element y in B. Now, I will write few examples, and with the help of example, I will give you the explanation. Let me have here, students, let me have here a set. I write a set A here, and which is, I write it as A, B, C, and D. Okay. Then I write another set B here, and I write 1, 2, 3, and 4. Or let it be only 1, 2, 3. Now you all know what will be A cross B. A cross B we will have A cross B as A1, A2, A3, then B1, B1, B2, B3, C1, C2, C3, D1, D2, D3. Okay, you have 12 elements here. This is A cross B. Now remember, students, I'm going to write here a subset of A cross B. Let me write a subset of A cross B. Okay, see here, I write a subset of A cross B. What is it? I write A1, A2, A1, A2, B3, then C2, and that's it. Now, understand, students, from the concepts of relation, you all know that this set which I wrote, it is a relation from set A to set B. This is definitely a relation from set A to set B. Why? Because this set, which is a set of ordered pairs, it is a subset of A cross B. But mind it, students, it is not a function. It is not a function. Why is this not a function? It is a relation from set A to set B, is a relation. It is a relation from set A to set B, but it is not a function from set A to set B. Now, what is that condition with which this relation is not satisfying? Why is this relation not a function? See, the condition lies here. The condition lies here. For each element, what is written? A function f from set A to set B is a relation from set A to set B which associates for each element x in A, there has to be an association. There has to be an association of each element x in A with a unique element, exactly one element in B. Now that is not happening. You can understand. See, there is an association of A with 1. In relation R1, there is an association of A with 1. There is a relation, there is an association of B with 3. There is an association of C with 2. But this relation fails to associate D with any of the element in B. See, in this relation, you understand that there is no association of D, which is in the set A. There is no association of the element D which is in the set A to any of the element in the set B. And that is why this relation fails to be a function. It fails to be a function. It is not a function. Why? Because there is no association of element D. It is clearly said what that when you say a function from set A to set B, when you say a function from set A to set B, then remember each and every element of set A should have an association with exactly one element in the set B. You cannot leave any element of set A. You cannot leave any element of set A. Okay. So now I am going ahead and I am writing another ordered pair, another subset of A cross B. Everybody see this. Now I write here A1, A2, B1, B2, C1, C2, D1. Okay. And then now here once again, okay, let me write this as once again. Okay, I will not write this as relation. Later we will talk on that. So here I have once again a subset. What is it? It is a subset of A cross B. Definitely. Why? Because every element here in this set is present in A cross B. So definitely this is a relation. This is a relation because you know a relation from set A to set B is a subset of A cross B. So if this is subset of A cross B, this is a relation from A to B, set A to set B. This is a relation. But is this relation a function? Let us check. Is this relation a function? I know many of you will say this is a relation, but this is a function. My question was, is this relation a function? I know many of you are thinking that it is a function, but let me tell you, students, this is again not a function. Why? Because it did satisfy the first condition. What was the first condition? The first condition was for each element X in A. Okay, each and every element that you have in A should be associated with exactly one element of B, exactly one element. See the second condition, a unique, that is exactly one element Y in B, which is not satisfied. You can check. A is associated with 1, very good, but A is also associated with 2, which is not allowed. A cannot be associated with more than one element of B. A is associated to 1, so A cannot associate with 2. A1, A2, not possible. See, B is associated to 1, B is also associated with 2, that is not allowed. C is also associated with more than 1, that is not allowed. So in short, you can say that a relation which has to be a function, in that the second component, if the first component should not repeat. Okay, the first component should not repeat. A1, so once you got A1, you cannot have A once again. If you got B1, then you cannot have B once again. If you got C1, then you cannot have C once again. Or in the other words, if you have A2, then you should not have A1. So what you can say, that first component should not repeat. Then only it can be a function. So once again, what I will say R2 is a R2 is a relation. R2 is a relation from set A to set B, set A to set B. Okay. And here for both I will write R1 is not a function, not a function. Why? R1 is not a function for two reasons. It is not a function, not a function for two reasons. First reason, see here, A has association with 1 as well as 2. This is one reason. A cannot have association with the two elements of B. Second reason is D has got no association. There is no association given for D. Same for R2. R2, what I will write, R2 is not a function. R2 is not a function. Now students, I will write one set which will definitely be a function, Now here I write, now I give you an example of function. Okay, enough. Now I should give you a function. See here, I write here. Let me write a set here. Okay, in this set, see what I'm writing. I'm writing A1. I'm writing B1. I'm writing C2. I'm writing D3. Okay, A1, B1. Okay, C2, D3, right? Yes. And this completes the set. Now, let's go one by one. Tell me, students, is this set a subset of A cross B? Yes. So this is definitely a relation from set A to set B. Yes. But you know, students, this is also a function from set A to set B. This set is a relation from A to B, but also a function from A to B. Why? Because it is satisfying both the condition which a relation should satisfy. What is the first condition? See, here from the set A, you got A, which has got an association. B also has an association. C has an association, and D also has an association with the elements of set B. Furthermore, you will notice, so all the elements of A, each and every element of A has an association with one and only one element of B. See how? A, B, C, D, they all have the association. So no element of A is left. Like here we had left D. Okay, so that condition is satisfied. Secondly, you notice that every element of set A has unique association. It does not have more than one association. Like see, A has an association with 1, and now A has no other association. See, A has association with 1. Now, do you have A anywhere else? No. Now B has an association with 1. Do you have B anywhere else? No. Now some students will say, sir, A has association with 1, B also has association with 1. That is okay. That is absolutely fine. If the second components are repeating, no worries. What is important? That A should not have more than one association. The association of A is unique. A has one and only one association from the set B, that is element 1. B also with 1. C is with 2. Do you have any other association for C? Do you have any other association for D? No. So this satisfies both the condition, and hence you will say this is an f. You will say is a function from set A to set B. It is a function from set A to set B. Okay. I hope you followed it. So students, let's come to one illustration, one example, one question, which is there in exercise 6.1 of your textbook, that is Maharashtra State Board textbook. A very good question here. The board doesn't matter because the concept remains the concept. See here. The question here is, check if the following relations are functions. You are given two sets, and then you have an association of the elements from set A to set B. Now see how the association goes. It goes as 2, -3. So this is kind of arrow diagram. It is kind of arrow diagram. It is not this relation which you are given. This relation is not in the form of set of ordered pairs. What I mean is, see, 2 - 3. It could have been given like this, 2, -3. Then 1 is associated to 1. So you could have been given 1, 1. Then 0, 2. You can check 0 is associated to the element 2. Then -1 is associated with 1. Then -2 is associated with 5. So we could have been given the relation like this, that is a set of ordered pairs. But in this question, they opted for giving us the relation in the form of an arrow diagram. This is also one way of giving the relation. It is one and the same thing. Remember, students, instead of giving the ordered pair, they are giving us the arrow diagram. Now the question here is this relation a function? And the answer is yes. The answer is yes. This relation is a function. Yes, the above relation from set A to set B is a function from set A to set B. Now, why do I say yes? See, the reason for saying that this relation is a function, because both the conditions are satisfied. What is the first condition? When you have a relation from A to B and you notice that all the elements of A are having a unique relation. When you notice that all the elements of A are associated with exactly one element in the set B. See, for example, how many elements do we have in set A? We have 5 elements, 2, 1, 0, -1, -2. So see, each one of them is associated. Condition number 1. Condition number 2 is that each one of them should be associated with exactly 1. So see, 2 is associated with -3, exactly 1, 1 to 1, exactly 1, 0 to 2, exactly 1, -1 to 1, exactly 1, -2 to 5, exactly 1. Now, some of the students would think that 1 to 1 and -1 to 1 both are related to 1. That is okay. What is important, that an element, when you say a function from A to B, then every element of A should be, first of all, having an association, and secondly, it should have only one association. You cannot have two arrows originating from a single element. You cannot have two arrows. See, if I had one more arrow originating from one, then it is not a function, because the uniqueness is lost. There is no uniqueness here, which I will give more light on in the next coming lectures. Okay, so what is important? There has to be one and only one arrow originating from set A, then only you can say it is a function from A to B. Okay. And if you see here, then what you can say, see the first component in any of the ordered pair is not repeating. See 2, 1, 0, -1, -2. First of all the elements of A are there, they all are present, and there is no repetition of the first component. Okay. Now see students, I would like to say something in the same example. So here it is a function. Suppose it had happened so that this 2, the element 2 in this element 2 did not have any association. Suppose it had happened so. And remember, if you were given any such arrow diagram, then we would have said that this is not a function. Why? Because the first condition itself is not satisfied. Remember students, for a function from set A to set B, each and every element of set A should have an association, and that association should be unique. So here you notice that -2 element has no association. So such a relation cannot be function. Definitely, see, if it is given like this, it means we do not have this in ordered pair thing. We do not have this element. So what do we call? We call this as a relation. See, this is relation. Definitely, it's a relation. Why? Because it is still subset of A cross B. This is also a relation, but it is not a function. Why? Because that -2 is missing, my dear students. -2 is missing. I hope now it is clear to you all.